part 3 of chapter 16 on base ionization reactions. So if you have a weak base, they will also form an equilibrium when they react with water. So if we have ammonia plus water, bases of course are going to take a hydrogen away from the water, so that's going to turn to OH, and then it's going to turn into the ammonium ion. So our equilibrium expression is going to be our products over our reactants. And then we can make the same assumption as we did for acids, which is because water is essentially the same concentration, we can move it over here and call this resulting product Kb, just like we do Ka for water. So in general, for any base reaction, you have your base, which is abbreviated B, plus water. Your base accepts a hydrogen and turns into this conjugate acid, so it gains a H and it gains a charge, plus OH. And your Kb is going to be written like this. Now the difference between these reactions is that we don't have this H3O plus in order to find pH. What we have instead is our hydroxide ion. So what we're going to have to do is first calculate pOH once we know our amount of hydroxide, and then find the pH from there. So it's just going to be an extra step to calculate the pH of these. So KBs have been tabulated also for most bases, so there is a list in your book, or it'll be given to you for a problem. So what's the pH of a solution of pyridine, which is a base? If you're not sure if it's a base, look to see if it says Ka or Kb. Kb, it tells you it's a base. So first thing we want to do is make our reaction and do our icebox for our concentrations, set up our K expression, and then solve for X, which is going to be OH. So it's the same basic steps. So here is our reaction. So our initial of our pyridine is 0.2. Water we don't care about. Initially 0, initially 0. Same thing, these are going to go down, your products are going to go up. So we know what our equilibrium expressions are going to be. Our equilibrium expression, in this case, is going to be our conjugate base, which is going to be, we'll do HC5H. You could also just abbreviate with your HB and your B if you want. So if we plug in the things we know, Kb was provided. Both the things on the top were x, so that's x squared. Our denominator, our starting amount of base, is 0.2 minus x. Now again, we want to see if we can simplify this by ignoring that minus x, so we can do the same simplification. The only difference is that instead of being Ca over Ka, it's going to be Cb over Kb. So my concentration of base was 0.2. My Kb was 1.4 times 10 to the negative 9th. So when we check to see, don't know what the answer is, but I do know it is much greater than 100. So 142 million. So yes. So we can rewrite our expression and solve for x. So when we do that, x is going to be equal, we'll do 1.7 to the negative 5th, which in this case is equivalent to our concentration of OH. So we can use that to solve for the pOH. So 4.8. And now pH plus pOH is equal to 14. Now, check to see if this makes sense, which it should, because bases should have a pH of 7 or greater. The closer they are to 14, the stronger they are. We know that this is a weak base, so it makes sense that this has a pH of 9.2. Okay, what is the Kb for a solution of N2H4 whose pH is known? So, we're going to write our reaction. This is my base. So this is going to gain a hydrogen. Okay. Our initial amount is 0.5. This is going to go down by some amount, up by some amount. So, our Kb expression. So in this case, I'm solving for Kb. So I have to be able to figure out what these three values are to plug in and solve for Kb. So I'm going to use the other bit of information I have, the pH. So in this case, pH isn't that useful because I'm dealing with a base reaction. So instead, I'm going to transfer this into a pOH value. So pH plus pH plus pOH, we know is equal to 14. .04. So how can I use that? Well, pH is also equal to the negative log of my hydroxide amount. I can also write this as that, which is going to be useful to us, because then we can solve for our hydroxide amount and plug it in. So 10 raised to the negative pOH is going to give me my hydroxide amount. So I know what this is equal to, which means I know what this is equal to since they're both equal to x. And I can solve for this. So 0.5 minus 9.12. So now I can plug all of these things in for my Kb. So these two are both 9.12. Minus 0.5 minus x. My advice is to do the denominator first, rather than trying to type it all in at once. But essentially, this whole thing is going to be equal to 0.5. So Kb is equal to 1.66 times 10 to the negative 6.